Hi, so now we are going to see how hot water recirculation system works. Well, first of all, we have the tank where the cold water is transformed in a way so that it gets hot, and when the water is hot enough to leave the tank, it is done in the pipe which is typically leaving the tank in the top, because the cold water eventually will become warm, and then it will go to the top, and then it's led out to the final consumers in the application. Well, if it's a rather widespread system where there's a long distance from the tank into the final consumers, there's a risk that the water will become cold when time has been quite long where there has been no use of hot water, when the water is standing still, in other words. In order to overcome that, we equip the system with another pipe where we place a pump, and this will enable us to recirculate the water in the tank and out to the final consumers, and then back to the tank again, so that we secure that the water in this pipe here will be sufficiently hot at all times. Well, if nothing is done, no valves or anything is equipped to the system, it will be a constant flow, of course. But we don't really want that. We want to secure that we have the needed temperature out here, nothing more, nothing less. So for doing so, we can equip the system, these strings here, with a thermostatic valve, which typically is set to opening and closing just around a temperature of 43 degrees Celsius or 109 Fahrenheit. So depending on the actual use in the system, these valves will actually open and closing frequently. So for that reason, of course, the final water which the pump needs to circulate will also be varying. And due to that fact, we need to calculate what is the actual pressure loss in the system, and based on that, we choose the right proportional pressure control curve, and then set it to operate by that. One alternative to this could be that if we don't have thermostatic valves here, but we have static valves instead, and then simply balance these two riser pipes up against each other so that we have the same pressure loss in these two riser pipes here. Then instead of having thermostatic valve, we now have a static kind of resistance in these two pipes here. So if we do so, then we could equip the system with a Magnet 3 pump, and then let it run by temperature control, and by doing so we secure that we run specifically on the system characteristic. And then here we can tell the pump to maintain these 43 degrees Celsius or 109 Fahrenheit, and then the pump will do all the varying of the flow, because it has this temperature control. It's a very innovative way of doing hot water recirculation, which I would strongly recommend. So let's see how hot water recirculation can be done in actually a third way. Well, if we have a very widespread system where we need the hot water recirculation at all, then instead of having one centrally placed pump here nearby the tank, we could actually challenge the system, or the predominantly thinking about how to do a system like this, and then place individually magnet pumps out here, because then each pump will secure that we have this minimum flow in the specific branch, and then circulate it back, the water back to the tank. Then we have complete control on each riser pipe here and know that we have the exact hot water temperature which we need at the final tap. That's a third way, and you can see all of the 3 different ways of doing hot water recirculation. You can see that in the small data booklet. I hope you will enjoy. Thank you.